Okay, fifth graders, we're going to continue into our world of fractions today, and we're going to begin to really talk about adding and subtracting fractions. There's some term we're going to be hearing over and over again, and that is this term like fractions. Like fractions are fractions that have the same denominator. We know that when we add fractions together, they have to have the same denominator in order to add them together. They have to be like fractions. They have to be the same size and equal pieces. So I can add thirds together. And so today we are going to be encountering fractions that do not have the same denominator and talking about what we do when we don't have the same denominator. Another term you're going to hear or talk about is related fractions. So related fractions are fractions where the denominator are related to one another. For example, if I have fourths, I can see how that could be related to eighths because I could change fourths to eighths, kind of that idea of fact families, if we will, right? So related fractions that are related. Okay, so let's take a look at this, and you can see that we're already starting with two fractions that are related, eighths and fourths. So let's think about that for just a moment. If I have, it says consider the expression, mentally estimate the sum or the difference, circle to show your estimation. So let's think about these fractions and what it's representing. 5/8 is that greater or less than half. So it's a little more than half. And then we have 3/4. Is that greater or less than half? Well, if I have 4 and I have 3 out of them, 2/4 would be half. So this is greater than half. So this is slightly greater than half. This is slightly greater than half, and if I add them together, am I going to have something that's less than 1, between 1 and 2, or greater than 2? So if you're saying to yourself between 1 and 2, that's correct. It should be a little greater than 1. Let's look at the next one. 2/3 minus 2/9. So this time we're actually looking at subtraction. So if I have 2/3, I'm thinking that's a little more than half. It's almost close to having 1 whole. And I'm taking away 2/9, and 2/9 is, that's a pretty small amount. But I think that I'm still going to have less than 1, right? Because this is less than 1 and I'm taking some away from it. It's still going to be less than 1, okay? All right, looking at our next problem. In these models, we are going to be trying to make like units, right? Like units, again, are units that have the same denominator. In order to add and subtract, we have to have the same denominator. So let's look. I have 3/4 plus 1/8. So we're asking to ourselves, what could I do to fourths to change them to eighths? So if you're thinking to yourself, well, I could multiply by 2, you would be correct. And you're going to see, we're going to be seeing this. Whatever we do to the bottom, I have to do the top, and that would be 6/8. So how could we represent that or show that on our model? Well, it's essentially, if I'm multiplying by 2, it's like cutting these in half. Okay, so let's draw some dotted lines here. So we can see that 3/4 is the same or equivalent fraction to 6/8. So 6 pieces out of 8 total, because now we cut them and we have eighths instead of fourths. So if we go up here, we're saying the equivalent 3/4 means the same as 6/8. and then we add 1/8 to it, and we get 7/8. So again, we have to change them to like units if we want to add or subtract. Okay, let's look at this one. Same idea. We're looking at related units, halves and fourths. This time we're doing subtraction. So I'm saying to myself, well, what could I multiply by to make this into fourths? Well, I could multiply by 2, and I would get 2/4. So we're saying that 2/4 is the same as 1/2. How could I show that on my model? Multiplying by 2 would be cutting this in half, cutting this piece in half, and then I would have 1, 2, 3, 4 pieces total. And this is still shaded in and showing that 1/2 is the same as 2/4. So now that we found that equivalent, we can now subtract because we have the same, we have like units. So 1/2 is the same as 2/4. And then subtracting 1/4, and I should end up with 1/4. Okay. Let's look at the bottom. Now they're not going to give us those units to look up. They want us to draw a model. So we're going to start with drawing our original fraction. So they're starting here with 2/3. So if I am showing 2/3, I'm going to have my rectangle. I'm going to cut that into 3 equal pieces. I'm going to shade in 2 out of 3 pieces. So this is my little tricky shading with a pen. If you have pencil, you could do this too. So that is showing 2/3. So I'm going to label what I've just drawn. This is 2/3. And they're asking me to change thirds to sixths. So what would I have to multiply by to change that to 6? And if you're saying to yourself 2, you're correct. Whatever I do to the bottom or the denominator, I have to do to the numerator. So 2 times 2 is 4, 3 times 2 is 6. And so how could I show that? Well, I could show that by that 4/6 is the same as 2/3 by doing my dotted line and cutting these pieces. Because when I multiply by 2, I'm cutting them in half. So now look at, I have 1, 2, 3, 4 out of 6 pieces. So 4/6 is the same as 2/3. So now I can put here, instead of saying 2/3, I can say 4/6 plus 1/6, because our units have to be the same. So essentially what we're doing is we are finding an equivalent fraction, a fraction that means the same as 2/3, but using sixths. Okay, so let's look at our next one. I have 8/10 minus 3/5. This time I'm going to look at the second fraction and ask myself, can I change fifths to tenths? Yes, I can. So we're going to draw a picture showing our 3/5. So I'm cutting it into 5 pieces. I'm not very good at that. Let's see, 1, 2, 3, 4 lines for 5 pieces. And then I have shaded in 1, 2, 3/5. So this is showing 3/5. But I want to change fifths to tenths. So I'm going to need to cut these in half. So we're multiplying by 2. Why am I multiplying by 2? Because 5 times 2 is going to give me 10. Whatever number I use for my denominator, I use for my numerator. 3 times 2 is 6. So this is showing, we're going to come up here, we're going to cut these in half. And notice I don't just cut the shaded pieces, I have to cut these other pieces too. Because now I've changed it to tenths, right? If I were to count these, it would be 10. The denominator is showing my whole, and then this is showing my amount. So this up here, the equivalent fraction for 3/5 is 6/10. Now I'm able to do my subtraction. So I had started with 8/10, subtracting 6/10. We're using our fraction equivalent, and I am left with 2/10. And if I want to get really tricky, I could say to myself, oh, well, 2/10, if I look down here and I see, remembering that these started out as fifths, I could say to myself, well, 2/10 is the same as 1/5. So 2/10 is the same as 1/5. Okay, you can do it.